Today I would like to give a bit of an update on Swarm and at the same time bring you a view on Swarm in terms of a toolkit that we provide as a set of base layer infrastructure services for the long coveted decentralized web that we termed Web 3. So Web 3 is this kind of idealized third stage of the internet when we go back to the old ideas of having decentralized services instead of the Facebooks and Googles of today, which is kind of a vision or bit of a dream. So what is Swarm? Originally, the scope of Swarm was to provide a data layer and like storage service and content distribution layer to the Ethereum ecosystem. So from very early on, like the Ethereum founders realized that the blockchain, public blockchain, is the final missing piece of the puzzle in the decentralized web. Because basically, with the public blockchain and smart contracts, during complete smart contracts, you can program incentive systems, which a lot of quite advanced peer-to-peer technologies needed to become self-sustaining. So to add economic incentive systems to make these services self-sustaining. So what is Swarm? Swarm is basically an incentivized peer-to-peer web. It provides integrity protection, fault-tolerant and censorship-resistant storage, and it's a genuine cloud service in the sense that so from a distance, like Swarm looks like BitTorrent on steroids, and maybe it's the easy way to explain to your friends what it is. However, if you look closer, it's not of a family of file-sharing systems in the way as like others like IPFS and the others are. It's a genuine cloud service in the sense that you can genuinely upload content to it. And Swarm is very opinionated about where certain content is stored. It's not that you open up your hard drive and you become seeder of a content that you already have. So what happens is that when you put up a document on Swarm, it's chunked into little pieces, and the little pieces, based on their content address or fingerprint, travel to areas of the network, to nodes which are closer to the content address of the chunk. So it's basically distributing chunks based on their address, and the address lives in the same address space as the individual nodes that form the decentralized distributed storage network. Okay, so what it gets us immediately is that because we use content hashes as content addresses, we immediately have like an automatic load balancing on the content, and we have integrity protection because the content addressing makes sure that the content is immutable. So if you have a hash that you know someone intended to show you a content with, then you can be sure that it's exactly what they wanted to show you. So there's no more hacking of websites in this paradigm. Now, one important thing is that how you map it to real world memorable names. So you use the ENS, the Ethereum name service for domain name resolution. And Swarm supports URL-based lookup. How does it work? You basically look up the domain name, which maps to a hash that contains a kind of a special data structure, which maps paths to hashes, to basically maps URL paths to documents, and therefore you can access document collections. This renders Swarm basically able to provide serverless hosting of whole websites, because with these manifests you can basically create a sitemap and access the individual documents on a site. So it's basically a serverless web hosting environment, with integrity protection, censorship resistance, and fault tolerance. So this is the basic introduction to Swarm. A bit of update. So last week we were fortunate to be hosted by the Research of Institute for Art and Technology in Vienna for our Hack Week, where we managed to round off the sprint for the very first POC 3 release, which is going to come out soon. This is going to bring major network resilience improvements and some other features. I'm happy to say that the Swarm team has extended substantially in the recent past, so our team is on fire and we're delivering new features. We have working relationships and working groups, collaborations with some companies. Notably, I would pick Status, Mainframe, Walk, LivePeer, and Data Fund, who are supporting us and working with us on various aspects of the Swarm. So, what am I going to talk about today? So basically in Shanghai was the first time when I kind of introduced a bit of a wider scope for Swarm as being a toolkit for infrastructure, like base layer infrastructure services for the web. And that's where I first talked about PSS, our decentralized messaging service for real-life communication, which uses the same network protocol and routing as basically as what it is responsible for chunk distribution and request handling in the Swarm network. We also talked about how the manifest idea, so basically indexing certain keys to content, can be easily extended to handle various database related data structures, and therefore it can serve as a database layer for Web3. This is kind of important for the mass adoption of these decentralized services, because it helps developers to carry over and migrate some of the knowledge that already exists with Web2. So in the current common method to build the real-time interactive web applications is to use is more and more common to use client-side rendering and most of the not so heavy computation, but most websites have a database backend which the client-side renderer communicates with through an API, and usually that database is still sitting on some server. If we want to move on to a completely serverless solution, then we have to provide decentralized database services, and this is exactly what we were working on with the help of Walk, a US company. And this will pave the way to finally put the blockchain and Ethereum state data on Swarm as well, to help the diversity of light clients. So what I would like to talk about is so in Shanghai and some previous talks, I already introduced some of these components and told you about how these components kind of as solutions to various infrastructure service problems kind of fell out of the design of Swarm, and some of this we kind of hit upon serendipitously. And today I would like to take a totally different approach and take a top-down approach and take you on a kind of imaginary journey, not so technical, in which I kind of lay out a typical use case, a rather banal use case of how we use the internet and digital services currently for a particular scenario. And I would like to comment on what components we use today and how these infrastructure services that we're building, we have built or we are in the process of building on Swarm, can contribute to replace and substitute these solutions. So let me talk a little bit about these components, but first let me set the context. So let's imagine that in a typical day, what you do, you come up with an idea that a group of friends wants to organize an event. The event is like a panel discussion, say, about ethics on the blockchain, and there's a group of friends who organize this, but ultimately want the panel discussion to be broadcast live. So what kind of stages there are in this process? Well, normally you would start some sort of chat group among these friends who are interested in organizing these events. You would probably use Skype or whatever group chat that you typically use, like Slack. And then you would start editing a document using your Google Drive or Dropbox. You would share something, and then you would do collaborative editing tools to edit, like, say the web page that you're going to put up as the public face of this event. You would then use some sort of server to put up this content. You would use the usual way to associate a domain name with the current version by adding the name service to your domain name host, and in a later stage, you would probably, how would you create an event? You would probably go to Facebook, create a Facebook event, and therefore make it searchable. And then when it comes to the event, you probably would use Google Hangouts, or some sort of Google service where you would do the same. So what tools are available that would help us replace these solutions? Well, first of all, you could use PSS, the PSS messaging, to organize the chat in the group. PSS allows for encrypted messaging and provides group chat. There's already a product developed by Mainframe called, I think the current name is Onyx. It's an alpha product which basically implements a Slack using PSS. This will obviously be only production operational once we have POC release out, and probably really reliable only when we have the production version of Swarm out. So this looks like, so sorry about that, this looks something like this. So what are the components that we might want to use? So when you share your document, you could use, instead of Dropbox, you could use the Fuse extension of Swarm, which is basically constitutes the backend for a Dropbox application. So what is Fuse? Fuse is file system in user space. It's a file system driver that allows the extension of operating system kernels to handle to write arbitrary file system drivers. What does it mean? We already have this implemented. It's been working for half a year. So you basically can mount a Swarm site or manifest as a file system on your local hard drive, which means that you could if you upload a directory and mount it as a local file system, you can write into it, and it behaves exactly like a Dropbox directory. Now, with using a hierarchical access control encryption, you can basically share. You can have the possibility to share the directory. So share one of your Dropbox directories as public, or share it with a select number of people that you want to share it with. So it's exactly this feature that we like to use in Dropbox or Google Drive, and so the infrastructure is there already in Swarm to do that. The encryption part is currently being developed. There's a talk by Donny on Friday that details our solution for access control and encryption in general. So what else is needed for co-ed, like for shared access content? Well, if you want to update your content from different devices or by different people, you probably need to update the changing mutable hash on the Ethereum name service. We also have another solution which allows for more frequent and cheaper updates to mutable resources. It's called Mutable Resource Update, or MER. And there's going to be a talk by Louis Holbrook on Saturday, which details this solution. I'm not going into the technical details now. But the point is that with this kind of resource updates, nodes have a way to check the particular versions of a mutable resource in the same way as they would be the ENS, with the difference that they don't need to be necessarily synchronized with the blockchain. They don't need to. They only need to retrieve particular chunks and data from Swarm to know what the current state of a mutable resource is. And most notably, to make an update, you just need to upload things to Swarm, and you don't need to send a transaction to the blockchain. But you can. That's also important, that any such resource update, which is obviously contains a signed, it contains a signature from the resource owner. It can be sent to the blockchain, to ENS, to consolidate the current state. So and then it can be sent by any third party. So let's move on to our imaginary scenario. What happens when we actually want to collaboratively edit a document? Let's say we are a bunch of geeks and we actually want to co-edit the HTML page that will advertise our event. So what do? There's an interesting feature of PSS, which allows not only like unstructured communication like chat, but it actually allows PSS, the PSS messaging allows for you to mount dev peer-to-peer protocol, an actual structured protocol over this encrypted remote communication, which means that, for example, you can use the decentralized version of the Google algorithm that handles real-time co-editing of documents. You can mount that protocol over PSS, and you immediately have a DApp, serverless DApp, which allows you to co-edit stuff. And you can have some sort of rule set which determines who's updating the current version on the resource update or the NS, and that way kind of make a kind of poor man's version of consensus over where you are in the what's the most current version. Of course, real consensus over this is only achieved when the hash is registered on ENS on the blockchain. I mentioned that the next step would be to actually create an event. So in our group, we decided that to have this panel discussion about ethics and the blockchain. So what would you do normally? You would create a Facebook event. In this case, what we can do is to use a decentralized database creation where we can create an entry for this particular event, therefore make it immediately searchable and indexable by venue and by time. It's all in the decentralized fashion, using this SwarmDB extension. And when we get to the actual event, what would happen? We could use live peers media streaming solution for video conferencing, and also for public broadcast of the video streams. So these solutions are all either have been completed or in the making, and probably going to reach production ready state with the POC 4 release in. I kind of predict that to be the first quarter of 2019 when all these components will become stable. So let's just recap what we have at the moment. We have the mutable resource updates implemented. We have PSS messaging implemented. We have the Fuse driver as the backend for Dropbox implemented. We are almost finished with the encryption implementation, and what we still have for planned only for POC4 is the database component and the actual incentive layer for storage insurance. So if you want to have more information about these actual components, then I encourage you to see some of the videos from DEF CON 3, because there's up a very good video about PSS, and it's also about this mainframe application. There's a talk, there's a London meetup talk, an hour-long talk, which details the generalized incentive framework that we're using, that we playfully termed swap, swear, and swindle games. These are basically generalizing the a framework in which you can program incentives and have service contracts and collateralized commitments of any kind of networked service, and also have peer-to-peer accounting via the swap system. And it's basically our glorified variant of a state channel, these swap contracts, and they basically implement some payment channels to help scale micropayments and microaccounting that is needed for bandwidth incentivization, for example, and for some various other services. So these components, again, Fuse, PSS, swap, swear, and swindle, mutable resource updates, and swarm databases are forming a kind of starting to shape up as a nice toolkit for Web3 base layer infrastructure, and you can use these components as kind of Lego pieces to put together modularly high-level applications or high-level services, which can ultimately, in this dream world at least that I have, replace current solutions. For example, Facebook, Google Drive, and Dropbox, and Hangouts, etc. So consider that. And finally, I would like to mention that we have, based on last year's success of the Swarm Summit that we had in Berlin in June 2017, we're going to have a new round. So this is going to be kind of a mini conference and a few hack days. The Swarm Orange Summit one, which is going to be in Ljubljana. This is the second week of May. And if anyone is interested in presenting or having a workshop or giving a talk on any topic related to decentralized web, especially storage and messaging, then please submit your abstracts or just give us a shout that you want to participate. Thank you very much, and I'm opening up to questions now. Sorry, I was not very agile in handling the slides because I became a bit off my medication, so probably people in the audience know that I have Parkinson's, and sometimes I struggle with timing my medication for the talk, so it's a bit hard right now. So please go ahead with questions. Yes?
My question is about geographic distribution. In a distributed way where everything can be anywhere, if we have a special case where some personal data has to be confined, can be distributed but has to be confined within a specific region, is there any way in a distributed system to
I mean, my kind of my cheeky answer is that no, and it shouldn't be anyway, because it's kind of a stupid legacy of a system where you know data was not globalized. How, I mean, there are kind of far-fetched solutions in which you can form a you can have like a set of nodes that register and promise to hold their data in a particular location, and they have somehow put that commitment or promise up on the blockchain. But even that is just kind of a positive promise that the data will be held there. There's no promise that other nodes outside that will not store it. So it's actually this is actually a very difficult problem to do on systems, or at least I don't know a solution. If you guys have any solution, then I'm happy to hear out. But in general, I don't think we want to support such geographical restrictions, because they are kind of even the concept is kind of alien to global distributed systems. Yes? Correct. 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 Thank you for the nice synopsis. It's exactly the problem. There's two pillars of incentivization in Swarm. One is for the smooth operation and of request handling. That is basically corresponds to rewarding nodes for their bandwidth contribution, and the other one is rewarding nodes for their storage, meaning that you have to compensate nodes for the missed opportunity to serve out popular content and get bandwidth incentives for them in favor of keeping your, I don't know, your birth certificate or some very private content that is typically not very popular or not retrieved very often. So for this kind of storage incentives, we use an insurance system, and that's going to be, so the question was when it's going to be implemented. So we had some prototype implementations. We have an article or a paper work in progress, which is called Swapster and Swindle Games, that describes this in a little bit more detail. And Ralph Pixler from Riyadh started re-implementing these contracts, and it's going to have a lot of iterations, of course, and especially it has to be combined with the implementation of our proof of custody solution, and I expect that to be ready only for POC 4. So it's going to be part of the production release then. And I think some early version is probably going to be in about half a year, and but the time when you can expect like really resilient Swarm and no data loss, that's basically only possible anyway. Even if the incentive is implemented, it's only possible if it's actually backed by real Ethereum tokens. So when the Swarm actually is going on the main net, yeah, because when the actual insurance system is properly paid with Ether or some other token, yeah. So that's when I expect resilient and lossless use of Swarm, only in POC 4. Did this answer your question? Yes. Yes, we are in contact with them, sure, and we have been in contact with them from very early on. In fact, Like they are kind of, we consider them as a sister project or even mother project, because they are kind of the Web3 hub of protocols. So we kind of have an agreement that swarm hashes will be available on IPFS, so they're going to be part of the registry in IPFS. The main difference between swarm and IPFS, if you look closer, there's two main differences. One that I mentioned before, that IPFS is kind of starting from the file sharing family of decentralized storage solutions, in the sense that you open up your hard drive with particular content and register that and publish that, register that content, and there's no genuine systematic way of distributing the chunks in a way that each chunk would have a specific space where it's supposed to be stored. In Swarm there is, and exactly for this reason, there's a genuine sense in which you can upload stuff to Swarm, even if you don't have any storage resources yourself. Now this has a lot of implications in terms of, because in this sense you kind of, as a Swarm node, you're forced to store other people's content. So we have to have measures of plausible deniability, which means that allowing tools for storers to deny that they know anything about the content of what they store. The other very important difference is that Filecoin, as far as I understand it, is providing positive incentivization only for miners, which might work out, but I have a strong suspicion that because it's basically socializes the risk of losing any particular file, practically this kind of losses will happen. Or if it doesn't happen, it's probably after the goodwill or lucky volume of available resources that it doesn't happen. There's no strong guarantees. In Swarm, we put a lot of effort into providing insurance solutions, which make the storers of particular chunks individually accountable, and therefore the threat of punitive measures is a strong disincentive against losing any particular chunk of file. I don't know if this answered the question. Any more questions? So go to Donny's talk about encryption and Luis's talk about mutable resource updates. Thank you very much.